All right, good morning. Today we're going to be talking about the common sense chord theorems. And we call them common sense chord theorems because, well, they make a whole lot of sense, as you will see. So our first common sense chord theorem says that if two chords are congruent, then their arcs are also congruent. And it works both ways. Now when we're talking about a chord and its arc, we're talking about, for example, chord DC would be this chord, and then the arc that goes from point D to point C. So that would be arc DC and chord DC would be the arc and the chord that go together. Same for EF. So chord EF, the arc that goes with chord EF would be the arc that starts at E and ends at F. So this theorem tells us that if segment EF, chord EF, is congruent to segment or chord DC, then their corresponding arcs are congruent. So that means that arc EF is going to be congruent to arc DC. And I'm writing with a mouse, y'all, so excuse the messiness. I'll try to do good. All right, and of course it does work both ways. So if we're given that arc EF is congruent to arc CD, then we would automatically know that chord EF is congruent to chord DC or CD. Alright, so in our example here, notice that the two chords are marked as congruent. We have those little congruence marks, so I know the chords are congruent. That tells me then that the arcs are congruent. So I could write an equation. Remember, congruent means equal to, so I could write the equation then that 3x minus 10 is equal to x plus 14. Alright, and then I would just have to solve the equation. So I want to get the x's together, so subtract x. And again, sorry that it's a little bit messy, y'all. 3x minus x would give me 2x. So 2x minus 10 equals 14. And then add 10 to both sides. And that would give me 2x equals 24. Divide both sides by 2, and we get x equals 12. Alright, so that's our first common sense chord theorem. Our next common sense chord theorem says that if our two chords are congruent, if and only if they are the same distance from the center. When you have an if and only if theorem, it means it works both ways. So two chords are congruent if they're the same distance from the center, and if you know that they're the same distance from center, we can say that the chords are congruent. So if we notice here from point O, the center of the circle, to segment CD, we have a congruence mark. Same thing over here, so I know that CD is the same distance from the center as AB. So since AB and CD are the same distance from the center, that means that AB and CD are congruent. So chord AB is congruent to chord CD. Alright, and again it works both ways. So if chord AB is congruent to chord CD, then they are the same distance from the center of the circle. Well, I would tap it in there so that it would be neater, but it won't work. So they are the same distance from the center of the circle. All right, and of course, from the last theorem, we know that if segment or chord AB is congruent to segment CD, then their arcs are also congruent. All right, so in our example here, we can see in the picture that from the center of the circle to chord XY is 4 units, and from the center of the circle to chord AB is 4 units. And it says that if XY is 10 units, what is the length of AB? Well, since they're the same distance from the center, they have to be congruent. So that means that if XY is 10 units, then AB is also 10 units. Alrighty, so there are our first two common sense chord problems. Alright, the next one says if a chord is perpendicular to the radius or a diameter, the chord and its arc are bisected. Remember, bisected means cut in half. So if I know that segment XY, the diameter of the circle, is perpendicular to chord LM, then the chord is cut into two congruent pieces. So notice that LZ is marked as congruent to ZM, and arc LX is marked as congruent to arc XM. So LZ is congruent to segment ZM, and arc LX is going to be congruent to arc XM. So in our example here, BC is 14, so that's this whole chord here is 14 units. We're supposed to find BD. Well, bisect means cut in half. Notice again it's marked perpendicular, so I know it's perpendicular. So that means that BD is half of BC, which makes it 7 units. It tells us here that EC, arc EC, so right here is 50. We want to find arc BC. Well, notice that arc BC is from B all the way to C. Okay, so it's this whole thing. So if this piece and this piece are congruent, and this one is 50, that means that this one is 50. So arc BC would be 100 units. All right, so here's some of these problems for you to try. So give these a shot, pause the video, and see what you can work out. All right, hopefully you gave these a shot. Notice that you've got chords that are marked perpendicular from the center. That means that, and they should have been marked not only perpendicular, but the distance here should have been marked as congruent. So if they're the same distance from the center, we can say that those are equal. So you should have set up your equation as 4x minus 5 equals 3x plus 25. And then when you solve that for x, you should have gotten 30. All right, for this next one, we're given that CB is perpendicular to AD. That means that CB bisects AD. So if AD is 28, AB is half of that, which means that AB should be 14. Alrighty, on this one, notice that arc TV is marked as congruent to arc ZW. If TB is 16, then ZW is also 16. Alright, and for this example, segment SR is given as 5x minus 3. Segment QR is 2x plus 21. Notice that the diameter MN is marked as perpendicular to chord SQ. That means that the diameter MN bisects SQ. So these two would be congruent. So you should have set up your equation as 5x minus 3 equals 2x plus 21. And when you solve your equation for x, you should get x equals 8. Alrighty, for this one, notice that the two chords are marked congruent. That means that our arcs have to be congruent. So your equation should be 2x plus 11 equals 4x minus 29. And when you solve that for x, you should get, 29, 39, 40. You should get x equals 20. Alright, and for this one, arc LP is equal to 100 degrees. Arc NZ is what? Well, notice that PL and NZ are marked as congruent. That means that the two arcs are also congruent. So 100 degrees would also be the measure of arc NZ. Alright, and last but not least, we have two chords below that are congruent. It tells us that YX, segment YX, is 6 units. So I'm going to mark that. So this whole chord right here is 6 units. And the radius of the circle is 5 units. We want to know the distance from the center of the distance from the center of the circle to either chord. So this is the distance we're trying to find. Notice that the radius is not drawn in there. So I'm going to draw in the radius. And drawing in the radius of a circle is something that's often helpful. So I'm going to try to draw this straight in there. There we go. That's 5 units. Alright, so notice that this segment is marked as perpendicular. So remember that if a diameter or a chord or a radius is perpendicular to a chord, it cuts it in half. So YZ or YX is 6 units. That means that this little piece right here is 3 units. And we're supposed to find X. Well, notice that we have ourselves a nice little right triangle. So when we've got two sides of a right triangle, remember we can use Pythagorean theorem to solve it. Alright, 5 is the hypotenuse because it's the one across from the right angle, so that's going to be my C. So I would write my equation as x squared, I'll have to go back and fix the squared, y'all, plus 3 squared equals 5 squared. Alright, so let me fix those squares. So what we'll want to do next is go ahead and figure out what 5 squared and 3 squared are. So we know that x squared, that's going to be x squared plus 9. I'm just going to use this as x squared, there we go, plus 9 equals 25. Subtract 9 from both sides, so x squared equals 16. And take the square root of both sides, and you should get x equals 4. Alrighty, hope that gives you a good idea about your common sense chord problems. Get started on your homework from your packet, and y'all have a great day.